Ayan. Hello. Rinig ba to?
Yes.
Okay, thank you. So hi guys. Thank you to those who showed up today sa review session natin for IE41. Um, yeah, we'll just go straight into it. We sent a samplex through the Facebook post nung Thursday, nung Thursday. And that's this. So basically, yung gagawin lang natin for those who are attending for the first time, i-run through lang natin yung mga sagot dito. And try to, as much as possible, show the process of how we get to those answers. So yun lang. I guess we can just start. Adam, are you recording na? I'm gonna assume you are na. Just so we don't stall for the people that bothered to show up. So, sige, let's first start just a true or false section. So all of these are just conceptual questions. So una, if an LP has an optimal solution when solved using the big M method, it also has an optimal solution when solved using the two-phase method. The answer there is just true, and the reason for that is, diba, they're both just different ways to solve. Um, they're both just different ways to approach yung simplex method. So yeah, they're basically just two different approaches. So if my optimal solution na nag-exist sa isa, there should be an optimal solution that exists for the other. So this is true. Yung second naman is, okay, so let's just move on to the second one. True or false, the feasible region of a linear program can be a point. Um, that is also true. And the scenario where that happens is, if you can imagine, I think the most intuitive one is like, if you have, let's say, wait, I'll draw. If you have two, so let's just leave x1, x2. If like for example, yung first constraint mo is x1 is equal to 1 and then x2 is equal to 3, right? So if you draw that, that would look like this. I'll just, yeah. So obviously, in that case, the only feasible solution, the only feasible region would be the point 1, 3. So same thing lang, it's just testing if you understand talaga what a feasible region is. In this case, it's just a single point kasi the constraints are both equalities. So, and that can be possible naman. So that's why it's true. For C, true or false, if the feasible region of an LP is unbounded, then it has no optimal solution. I think lumabas to, if you're Sir Mark, it showed up in a quiz somewhere. Or baka I'm misremembering. But this is false. The reason for that is, if you take an infeasible region, for example, like, sorry, if you take an unbounded region, let's say, eto. Let's say these are two constraints, and this is the feasible region, diba? So let's say, ano siya, pag ganito. This is the feasible region. If you, for example, have, kasi optimal solution lang eh. That means na pwedeng minimization. So, for example, if if you have a function, let's say min z equals x sub 1 plus x sub 2. Technically, diba, it would be here. Like, you guys can see it naman, right, na if we, for example, plot this, it would look like ganito lang. And as you move the objective function, dito siya mag-minimize. So technically, even though it's unbounded, kasi this extends to infinity, technically, nagkaroon pa rin siya ng optimal solution at this point because you have a minimization function. So this is technically not true, so it's false. For number 5, an LP can have exactly two optimal solutions. The answer is false, and the reason for that is, let's look at the three scenarios. Kung ano yung three scenarios for wait, sorry, di pa pala. True or false, a degenerate LP has no optimal solution. The answer is false kasi a degenerate LP just means na you have more than, kasi diba, yung rule is, so a property na we have is, if you have an intersection between, wait, that's not, it's the intersection of two constraints, that automatically means that you have a corner point, which is a candidate for the optimal solution. But there are cases where, let's say, may ganito ka na feasible region, or may ganito ka na LP. Yeah. And let's say it's like, just for simplicity, ganyan siya. Like, if you draw it graphically. So, dito na section, ito yung feasible region. So, all its corner points are these. At this point, you have it's defined by three constraints. So, that's the definition of degenerate LP. Kasi what happens is, when you do the simplex method here, lalabas na you have, um, what we call cycling. So that just means na when you're doing like simplex, you're gonna return to the same set of basic variables. So parang when you're moving across points, parang babalik ka to this point because it like messes up yung paggawa ng simplex. So TLDR, what that just means is, it affects how you might have to do simplex differently kasi it messes with the algorithm. Pero it can still have an optimal solution. So like, let's say even at the point of degeneracy. So like, let's say yung objective function mo is this. It's still technically an optimal solution. So even if degenerating LP, you can still have an optimal solution. So uh, the answer to this is false. Yeah. Okay. Let me just move yung underline. Okay. Next is letter E. True or false? An LP can have exactly two optimal solutions. As I've na spoil ko na kanina, the answer to that is false. And let's look at the three scenarios for for what kinds of like optimal solutions we have. So the first one is obviously pwedeng walang optimal solution either because unbounded siya. So for example, something like so let's take the constraint z1 plus z2 is equal to is less than 1, and then z1 sorry, x1 pala. Okay, x1 plus x2 equals less than or equal to 1, then x1 plus x2 is greater than or equal to 2. So pareho silang parallel lines dito, pero opposite directions siya. So in that wala siyang intersection. So then, therefore that means, pag no feasible region, automatic no optimal solution. Right? Because di ka makakagawa ng feasible region, which is where you'll find optimal solutions, where you'll find yung corner points. So automatically, you just can't find an answer. So that's the first case. The second case is where it intersects a point, diba? So let's say, let's say, like, I don't know, ito, tapos, sorry, my pen is not working properly. Ayan, so, let's say the object, so ito yung corner points, and then the objective function is like this. So, in this case, 1, yung optimal solution niya. The third case naman is pag infinite siya. Or pag infinite meaning, let's say, same setup. Parang pag ganito siya. Yung constraints, uh, yeah, pag ganyan. Pero the objective function is like this. So, ibig sabihin, all the possible optimal solutions exist along this line segment. So, it's parallel to a constraint. Therefore, you have like alternative optima yung term yan. So, ibig sabihin yan, the scenarios that you can possibly have, so yung possible number of optimal solution is either 0, 1, or infinite. Ibig sabihin, it is false na an LP can have exactly 2 optimal solutions. Because it's either the case na wala kang optimal solution, or it intersects, it only hits 1 point, so you have 1 optimal solution, or it hits a line along the feasible region, and therefore you have infinite. So, it is false. Your last naman is true or false. If a point in the feasible region is the optimal solution to the LP, then it is always a corner point. That's just true. And this is basically a property lang. So actually, this needs to be memorized or needs to be remembered. Kasi that's just an intrinsic property of optimal solutions. It is always a corner point. So all optimal solutions are corner points, but not all corner points are optimal solutions. Ay, yeah, tama. Actually, wait. The optimal solution has to contain a corner point. Kasi if it's like infinitely many, kasi it's parallel, pwede naman siyang along the line. Pero it always contains either 1 or 2 corner points. 1 pag isa lang, 2 if infinite along a line. So, yeah, all optimal solutions are generally corner points. Wait, so actually, sorry, I'm just referring to Jerome kasi uh, he's supposed to be the one doing this, pero he'll be late, but that's okay. Wait lang, let me check. Actually, this is technically sa optimal solution to NLP. So this is technically false pala, sorry. This is false, and the reason for that is pwede kasi siyang pag infinitely many, wait, what letter is this? F. Kasi technically, if I'll just copy kasi it's the same exact concept. Pwede kasing yung optimal solution is here. That's not a corner point. Pero you can always tell optimal solutions based on if it, like, you always look for candidates along a corner point. Pero pwede kasing yung one of the optimal solutions, so you have infinitely many here. These are not corner points. So technically it's false. Yeah, this is actually quite confusing. Pero it is the case nga na this is false. So that's for the first part. If you guys have any questions, please say now. Or you guys can just chat or ask. Pero I can't see the chat. I'll just check na. Okay. Malinaw pa naman so far. Is it good? Okay. I'm gonna assume that's the case. Okay. Sige. So let's move on to the next section. So ito naman, items G to L consider the following feasible region of a maximization LP. So, okay. So this is the feasible region. So let's just go through this one by one. First, assuming there are no redundant constraints, including non-negativity constraints, how many constraints define the given feasible region? So, um, recall natin na one of the properties of linear programming is na all the variables you're working with are linear. So, first power. Ibig sabihin yan, you will always have straight lines if you graph out a linear an LP. So, ibig sabihin yan, it's safe to assume like na all these lines, oh my god, oh, all these lines are different individual constraints. So that's how we got to this. Right? Kinombine natin lahat ng mga constraints na to. So ibig sabihin yan, we're sure that there are 4 constraints. Kasi assuming there are no redundant, so walang constraint na hindi nakikita. So there's no constraint that's like this, and parang di siya nakikita sa graph. So ibig sabihin yan, we're sure that there are 4 constraints. So that's for G. For H naman, if a simplex algorithm was used to solve the optimal solution to the LP, how many non-basic variables will be there in each iteration? So let's recall lang muna, and I guess it's most useful to visualize simplex table here or a tableau. Isipin natin, nag-apply tayo ng simplex algorithm. So we don't have to know every single function here or every single constraint or even the function itself kasi hindi siya given. All we know lang is we're gonna perform simplex. So recall. So from a simplex table, diba, you have z, you have decision, and then you have slack or surplus, and then you also have yung artificial variables if needed, and then right hand side. Yung linalagay dito, these are called the basic variables, diba? Ibig sabihin, when find at the corner point, these are the set of variables that have values, right? So the the only set of variables with not the only set of variables not equal to 0 at corner points. Okay, so ibig sabihin yan, we can just kind of reverse engineer it na we can find the amount of non-basic variables by taking all the possible variables minus yung basic variables. So so the next question you want to find out is how many rows are in a simplex table for a given LP? Obviously, diba, one row is equivalent to one constraint. So now we know na we have 4 rows. We probably have 4 rows, right? Here. So now we know how many basic variables are there. The next thing we want to find out is how many variables you have in general. The way we figure that out is just by checking each single one. So una, check natin yung decision variables. Because this is a 2D LP, these are our 2 decision variables. So we have 2 decision variables, x sub 1, x sub 2. Second is slack and surplus. We don't have to know the exact functions nga. Kasi we can tell from these pa lang na these are all inequalities. Kasi pag ganun sila eh. Like, hindi siya strictly an equality along the line. Ibig sabihin, regardless if this is greater than or less than or whatever, we know na this will always have either slack or surplus. So each constraint has slack or surplus. So that's another 4 now we can add here. And then in terms of artificial, diba artificial, we usually only add it if wala tayong starting BFS or So this is the, so if wala tayong BFS, if no BFS. And typically, the default BFS is the origin, 'di ba? Kasi it's the simplest to, figure out. Mag-zero out ka lang ng x sub 1, x sub 2. So, in this case naman, dito yung origin. So, it is part of the feasible region. And therefore, we have a starting basic feasible solution. So, ibig sabihin yan, we don't need to input any artificial variables. So, since we have 2 plus 4, 6 variables, and we know now we have 4 basic variables from the rows. Therefore, yung amount of non-basic variables will be 2. Yeah, 2 non-basic variables. So yeah, that's for H. That's basically it. So for I naman, so we're moving on to I na. Give an objective function that will yield 0.76 as the optimal solution. I guess kasi maraming possible answers dito. I'll just walk you guys through siguro how I would approach this. So the first thing I would test lang is if I can get away with just using one variable. So check ko yung along x1. It's not the case kasi if my vertical ako na function, 8, 4 yung matatamaan. So it doesn't work. Along x2, same thing. It's not the first one na matatamaan. So 7, 6, I have to think of something. I mean, pwede din namang we can try if, I don't know, something like x sub 1 plus x sub 2. So, if you visualize it lang, and like you draw it to scale, pag ganito siya, and then you keep maximizing. So, yan, I would. Di siya dapat parallel. Something like this. So, okay, parang it works, right? X sub 1 plus x sub 2 works. So, ibig sabihin yan, and if you run the numbers, if you check talaga, pwede yung x sub 1 plus x sub 2. So that's basically how we can figure it out. I-test lang natin to scale if it makes sense na yun yung yun yung maging optimal point. Pero we can also just siguro what you can do is check nyo na lang if it ends up like being this line or this line. So, mag-guess kayo and then check if it also applies to these, yung adjacent yan na corner points. If not, then that's the answer na. So, that's just much faster than doing it manually. So, like, make an intelligent guess and then check if it applies here. If it doesn't apply there, edi, yun na yung sagot. So, that's for I. Basically, like, intelligent guess lang. Next naman, 4 and then 7.5. In this case, yung tinest natin kanina yung x2, it does land there. So even something like maximize z equals x2 will yield this as the optimal solution. Kasi ito yung pinakamalayo. Like when we're increasing z, ito yung last na matatamaan. So, ibig sabihin pwede na yung function, like maximization function na z equals x2. So yeah, that's for that section. May dalawa pa from the same part na nasa different page. Give an objective function that will yield the origin as the optimal solution. Obviously, minimization function lang yung ganyan. So you can just take any minimization function na would hit this instead of these two. So same thing lang. You can test with something simple like z equals x1 plus x2. And if you look at it like visually lang, pag minimize siya ng minimize, dito yung last point before it leaves the feasible region. So, ibig sabihin yan, kahit z equals x1 plus x2 lang, already satisfies the origin as a Yeah, it already satisfies the origin. Um, okay, wait. I'll just write everything down para I can upload this later. Okay, so the last one is give an objective function that will yield both 6.50 and 8.4 as optimal solutions. So, if they both have to be optimal solutions, so recalling lang yung ginawa nating explanation for, I think that was letter E. Um, Ibig sabihin, if you have two corner points, yeah, in there, if you have two corner points, that probably means that the entire optimal solution is parallel to a constraint. So yung sabi is 6.50 and 8.4. So that's this line. So we just have to find uh this what this line is. And what we can just do there is yung simple ano lang, line slope form. So, 'di ba? Y equals mx plus b. Babaguhin lang natin yan to x sub 2 is equal to m x sub 1 plus b. So, I'll just move down para mas kita yan. Anong letter to? This is L. Okay. So, uh, yan. So, so now, let's just take first x2. So, that's the first half of the equation. Equals m x sub 1 plus b. So, x sub 2 is equal to, so slope is just rise over run. So, yung rise dito is from 6.5, like, let's just arbitrarily set 6.50, nag-move siya to 8.4. So, the rise is 8 minus, um, 8 minus 6.5, and then the run is, 8, oh, 8, that's 4 minus 0, right? So, 8, 4, 6.50, x sub 1 plus b. So, then, um, we'll get na this is 2.5 over 4, which is 8 over, right? Okay, wait lang. Ay, oh my God, okay, nabaliktad ko yung, ano, so this is, rise pala is 4, then the run is 6.5, 8 minus 6.5, sorry. 8 minus 6.5. So, ibig sabihin, 4 over 2.5, which is equal to 8 over 5. So, that's the slope. So, that's the first part. 8 over 5 x sub 1 plus b. The next thing we'll do is just test test it on the point. So, let's just pick 6.50. It's more convenient. 0 na yung isa. So, 0 is equal to 8 over 5. 6.5 is just 13 over 2 plus b. So, then, uh, okay. So, okay. Actually, you don't even have to get this kasi it's at the bottom. So we don't have to, well, technically we can, but we don't have to. So let's just do it. So, 440, 52 over 5. Negative 52 over 5 equals b. So, ibig sabihin na this function mismo is x sub 2, if we move everything around, um, negative 52 over 5 equals, wait, let's just make it proper looking. Negative 8 fifths x1 plus, negative 8 fifths x1 plus x2 is equal to 52 over 5. So this is the line that's exactly parallel Pero it only really has to be parallel. So, kung isipin nyo nga, yung function is z equals something. So, we know it's minimized at z equals 52 over 5. Pero we can just effectively put, kasi it has to be minimization. And the reason for that is, if this is the line, we don't want it to go up further and further. Kasi then it would be here. So we have to make sure na it's a minimization function. So, kasi nasa bottom siya. So, minimization z is equal to negative 8 over 5x1 plus x2. So, yun lang yun. That's what basically gets you this answer. So, that's what gets you yung line parallel to this, which is what we're looking for. So, that's basically the first uh, part. Do you guys have any questions? I'm gonna assume none, but I'll check the chat. Uh, Assuming, wait lang. Which question is this?
Oh, that was a while ago. Like the which lines? What do you call that? Which lines define the shape of the feasible region?
What lines? Okay, okay. Yeah, this is G, diba? Oh, yeah, assuming
Yeah.
northern, including, yeah. So, how many constraints define the given feasible region? Yeah, if you don't count the non-negativity constraints, technically it's 4. Including non-negativity constraints, uh, you just add the 2, so nagiging 6 siya. Pero yeah, um, yeah, that's technically right. Actually, I think it's more correct to say 6. Pero in terms of applying simplex na, you're really only working with 4. Pero yeah, you're right. I think if the question just says constraints, negative, like, medyo weird nga yung grammar eh. If there, so if, no redundant constraints, including non-negativity constraints. If it's asking you to include it, like separate clause yung dalawa, then it's 6. If it's asking you na there are no redundant constraints and no negativity constraints, then it's 4. So it's just weird lang yung grammar. I guess 4 or 6, depending on yeah. Okay. Thank you for pointing that out. But yeah, technically both of those are true depending on how you read the question. So yeah, that's wait, I'll just put this as well. I mean G is equal to negative 8 over 5 x1 plus x2. Okay. Siguro we can do a bit of problem 2. Ay, ayan. Oh my god. Okay. So Jerome is ready to take over na as originally planned sana for this review session. I just also want everyone to know na Jerome took out time from his birthday to teach us all IE 41. So let's all thank Jerome for this labor of love. And happy birthday, Jerome. We're, start streaming na.
Labor of love. Okay. Thank you. Hold on. Okay, so go to problem 2. Before we start, or was there something we need to know first for problem 2 is to review like yung cases for special cases. Do not disturb muna. Special cases. Wait, I'm audible naman na. Yes? And the
Yes.
stream is seen.
Yeah.
Amen. Why is my handwriting like that? Okay. So special cases for LPs. First of all, infeasible. If the ano to? If there's a non-zero artificial variable, and then for unbound, so that's when like it will go on and on and on in the direction that it needs to be optimized. If you know what I mean. Like if kailangan maximum siya, but the function, the feasible region just goes all the way up. That is like a symptom of that is if there is an entering variable, but there is no leaving variable in the simplex table tableau. And then alternative optimum. That's if in the objective function row, there is a non-basic variable that has a non with a zero coefficient. Tama ba? Zero or yes, I think. Yes. Then last one, degeneracy. I don't know if baka na-discuss na to ni Hugh, but anyway, if there's a BV in any part of the simplex tableau, if at any time there's a basic variable but it's equal to zero, then there is degeneracy. Okay, so sorry guys, medyo wala pa ako sa zone. This is the first review session of the semester. This is so awesome. Okay, so problem 2 for letter A. So I wait. Let's read out the instructions first. So answer each item independently of others. So A, B, C, D, and E are all different situations, and give a range of values for all letters so that the given conditions are met. So letter A first. The current iteration is optimal, and the linear program has alternative optima. First thing I want us to note is I feel like medyo weird yung conventions nila noon because this is from 2017. So usually for us, diba, pag simplex, dapat maximum na siya. Meaning, like, if it's optimal, dapat everything in the objective function row is non-negative. But it's asking for us to give a situation na optimal na siya. But as you can see, there's these -4 and -3 na we can't change. So I think back then, like, not necessarily ginagawa nilang maximum value maximum function yung objective function. So in that case, I think nasa slides naman siya as like a footnote that if you're doing simplex tableau on a minimized function, then instead of the most negative, you pick the most positive as the entering variable. But I feel like hindi siya mag-appear sa exam natin. But, good to know din. So anyway, for the current iteration to be optimal but have alternative optima, let's go back to these cases. So there should be asan ang laser pointer? Yeah, there should be a non-basic variable with a zero coefficient. So they already told us here dun sa left side what our basic variables are. And you can also tell from yung columns nila. So x5, x2, x3, and x7 are the basic variables in this iteration. Meaning, one of the paste the picture into. Check. My God. Wait lang. Daming pictures. Then save. Ayan. Here. So, where was I? Let's highlight the basic muna. So that's x5, x2, x3, x7. So one of the non-basic ones should have a zero coefficient. So that's x4 or x6 or x1. Since x4 and x6 are already given a -4 and -3, we know that at least a should be equal to 0 just to satisfy another's alternative optima. Then we can also already say na b are equal to 0. B is equal to 0 rather, since since what again? Since x3 is a basic variable, so that means na everything except itong one on the row of x3 are 0. And then what else can we choose already? So C, since C is just the optimal value, that can be anything. So C is anything. And then what else? Let's just go like per letter. So D over here, it's on the right hand side, and we know that when we're doing simplex tableau, you want the right hand side, except for the one on the objective function. The right hand side should be positive. And then what about E? Where is E? E is here in the column of x1. We don't really have any restrictions for that right now. So E is also any. Sorry, medyo magulo yung arrange. I'll try to hurry it up because the next item is also pretty long. Okay. F, any also because it's just the right hand side. G, 0 also. It has to be 0 since it's on the column of x2, which is a basic variable. H can be anything. And then I can be anything also. Then J can be greater than 0. So, ayan, that's the answer for letter A. Then B, the iteration is not yet optimal. X3 is the leaving variable and X4 is the entering variable. So, in this case, since again, so the iteration is not yet optimal, X3 is the leaving variable and X4 is the entering variable. Okay, so for the X4 to be the entering variable, we want it to be the most negative. Or like, we can like change the situation here. Since medyo weird nga siya since they don't follow the same conventions as us. Let's say na we're going to treat the objective function as the most as a maximization function. So first thing we can say is since we want x4 to be the entering variable, it should be the most negative in the objective function. So that means A should not be more negative than -4 since it's in the objective function row. So A should be greater than -4. B should still be equal to 0 since we're starting off with x3 being a basic variable. And then C can be anything again. Then D. Okay. This is where it gets kind of weird because we're trying to asan yun? We're trying to make x3 our leaving variable. So that means the ratio of x3 on the column of like the ratio of x3 on the column of x4 should be the lowest ratio, which is so the ratio of x3 right now is 24 over h. So we want that to be lower than all of the other ratios, which in this case is d over 2, f over 3, and j over 3 halves. So we can start. What we actually need to do here is control the values of d, f, and j so that they will always be lower than h, or so that the ratios will also always be higher than the ratio involving h. So just transpose. So this one is gonna be d over 2 is greater than 24 over h. So d should be greater than 48 over h. And then same thing with f over 3. Let's skip e first. Make f. So transpose lang na naman. Times 3 times 3. So f should be greater than 72 over h. G, h, I, j. And then j over 3 halves should be greater than 24 over h. So just multiply both sides by 3 halves. Yes. I think I did arithmetic wrong on the thirds. J times 2/3 should be greater than 24 over h. So multiply both sides by 3 halves. J should be greater than 24 times 3 halves over h. Ay, di naman. Tama naman. Sorry, guys. Okay. 36 over h. So now we still have E, G, H, and I. So for h, it can be anything as long as, since we want x3 to be the leaving variable, the ratio should not be, the ratio has to be defined and it should not be negative. So basta positive. H just needs to be positive. Then for letter G, damn, this is a really weird question design, no? Okay, G should be 0 also because it's also on the basic variable row. And then I, anything, we don't really care. E, anything, we don't really care because it's just, remember, this is I, this is E. So it's not really involved in any of our decisions right now. C, 8 p.m. na. Okay. So the linear program exhibits degeneracy. So go back to the definitions. Degeneracy is when one of the basic variables, is equal to 0. So what we need to look for here is how can we make one of the basic variables equal to 0. So basic variables again are x2, x3, x5, and x7. So we only need to look at the highlighted columns because if you remember, yung non-basic variables, they're already equal to 0 in this system of equations. So if we want to want to make it so that any one of these basic variables is equal to 0, copy this. Okay. So let's start with how can I make x5 equal to 0? That's it. That's simply if d is equal to 0, since 0, 0, 1, 0. So if d is equal to 0, that means x5 equals 0. So you can follow that same pattern. F equals 0, j equals 0. For this one, you can see since g is on this basic column, g also has to be 0. And since theta's the right hand side, it's fixed to 24. There's actually no situation where we can make x3 the degenerate variable. I don't know if that's actually a term, but you guys know what I mean. The variable that makes the LV degenerate. So just for it to exhibit degeneracy, only one of these needs to be true. So you can just, you can just write that. So at least one is true. Then we need to fix the conditions for the rest of the variables. Nagpapatagal talaga eh. Anyway, so A can be anything. B should be 0 since it's on the on that. Yeah, alam niyo na. I've said it like so many times. C, C can be anything since it's just okay. I'm not gonna add a reason for everything kasi repetitive na masyado. Then D needs to be greater positive. So make it greater than or equal to 0 since we are including the case where it could be the degenerate variable. E anything. F positive. G 0. H anything. I anything. J non-negative. Okay. Blasted through that one, Medj. Okay, let's go to letter Z. So the objective function is maximization. And x1 is the entering variable and the linear program is unbounded. So go back to the conditions for unbounded. So there should be an entering variable but not a leaving variable. Whew. So they already determined for us what our entering variable is going to be. It's going to be x1. So since the objective function is maximization, we want the coefficient of x1 to be the most negative in the row. So what you just need for that is for a to be less than -4. And then b, since it's also in the objective function row, just make sure that b is greater than a. Hey, wait, sorry. It's on the column of the basic variable, so b has to be 0. C can be anything. D should be non-negative. Okay, hold on. And then, hold on. Let me find the column for x1. Column for x1. So these are the Ooh. These are the variables that we're looking at for the ratio. Okay, so the ratio of x5 is d over -4. So just for the ratio to be 0 or negative, since we want all of these basic variables to be ineligible to exit, just make sure that d is greater than or equal to 0, so that its ratio will only be 0 or negative. And then the condition for the next row, basta f over e. And then the same thing for this row, j and I, j over I should be 0, negative, or undefined. This is very wordy, but you know, they just asked for the condition, so it works. And then what's next? What have we not covered? Okay, so G should be equal to 0 since it's on the basic column. H can be anything. Yeah, because it's not affecting our decision. And then I can be anything. Oh my god. J should be non-zero. Non-negative rather. Since it's on the right hand side. Okay. Next na. God. Okay, so the current iteration is optimal. So repeating from last time, since we have fixed negative numbers in the objective function, we're assuming that this should be optimal for a minimization function. So A should also be negative, since for minimization, it's optimal pag everything is non-positive. So or it can also be 0. But then B should be equal to 0 since it's in the basic column. C, anything. D, D, non-negative. E, anything. F, non-negative. G, 0 because it's on the basic column. Oh, this is so excruciating, guys. H can be anything. I can be anything. J should be non-negative. Sana di ganito yung questions natin sa actual exam. Anyway, so that's it for problem 2. It's super like heavy on definitions. So, ayan. I opened the chat. So if anyone has any questions, ask muna before I move to problem 3. If not, pasend na lang ng hearts. May nag-heart na ba? Is that your heart? Why is your heart clapping? Okay.
Well, yes. Okay.
Well, yes. Okay. Oops. Next problem. Asan na yun? Okay. Oh, I could have just duplicated the other one. Here, LP formulation. LP formulation is probably like the funnest thing in this LE. So, I don't know. Just find a way to make it feel fun for you so that you don't feel the excruciatingness of it. So, and I guess I'll read out the whole problem. So Miko is a sauce producer for Branky's chicken wings and specializes in 2 sauces, Kasama and Luzon. Branky's buys a liter of Kasama for 250 pesos and a liter of Luzon for 230. Kasama is produced in plant K, while Luzon is produced in plant L. The 2 ingredients needed to produce the 2 sauces, Laf and Sal, are sourced from 3 warehouses. A liter of Laf and a liter of Sal costs 50 pesos and 65 pesos respectively. Regardless of the warehouse it is ordered from, Miko must shoulder the cost of transportation from the 3 warehouses to the 2 plants. The transportation cost per liter and the maximum supply of LAF and SAL from each warehouse is given in Table 1. So, ayan, tignan nyo na lang yung table. Oh my god, my stream is blocking everything. I'm so sorry. Okay. In order to produce kasama, the two ingredients must first undergo a filtering process. However, this reduces the available amount of LAF and SAL that can be used. After undergoing the filtering process, only 90% of LAF and 80% of SAL that was processed will be available for use. That means if 100 liters each of LAF and SAL was fed to the filtering machine, only 90 liters of LAF and 80 liters of SAL can be used to make kasama. It costs 10 pesos per liter to filter LAF and 15 pesos to filter SAL. The LAF to SAL ratio to make the kasama sauce is 5 to 4. The process in making the Luzon sauce is much simpler. LAF and SAL are simply mixed at a ratio of 1:1. However, there are only 12 mixers in plant L, and each mixer can only hold 100 liters. The cost of mixing the Luzon sauce is 20 pesos per liter. Formulate an LP for the optimal production plan of Mejos. So let's highlight like important stuff. So oops. So this is the presuming what the optimal production plan is. So since it's a company, guess what companies do in a capitalist world? They want to maximize profit. So that's one thing down. Honestly, this is really like, even when I was solving it for the first time, it can be really daunting. But, you know, you really just have to start on it. The first step is to try. That's what I always tell people. Okay. Anyway, so just keep in mind first, this we can remember this will help us along the way. Maximize the profit, which is the revenue, minus the costs. Oh, okay. Let's highlight everything else. Laugh and sell. That's just context. Okay, then these are the costs. Cost. The cost. Then the table is important, but I won't highlight all of it. Then only 90% laugh and 80% of sell. Which one's then 10 pesos per liter. Then show. Ooh. Pangit ng pag-highlight ka. Whew. Okay. So, first thing we want to do, I think, what I think is a nice first step is let's identify first our sources of revenue and our sources of costs. So, we know now, first of all, the main product of the company are the sauces, kasama, and Luzon. So, how do they get revenue from kasama, and what cost? How do they get revenue from the sauces, and what costs do they incur from the sauces? So, revenue for kasama is simply 250 per liter that is made, then 230 per liter that is made for Luzon. Then the costs of kasama and Luzon for kasama. It's the cost of the sausage, the cost of the ingredients itself. Actually, yung costs, yeah, since yung product is like yung end, yung kasama and Luzon is yung end product nila. Actually, these costs mostly refer to the ingredients, laugh, and sell. So the cost of the ingredients, laugh, and sell. And then the transpo of these ingredients. And then for kasama, the filtering. Then for the zone, it's also cost the ingredients, transpo of the ingredients. But instead of filtering, there's a cost for mixing. Whew. Okay. So next thing you can do is define your variables, and you have to think about like just how many variables are you gonna need. I think a big hint to how many variables you need is the fact that here we have this. So for each ingredient, the transfer cost is different for which plant it goes to. And then each plant will also receive a different quantity of what's it called? Of each ingredient from each warehouse. So let's start off basic. So let's just define K to be the liters of the kasama sauce produced. And then U, since mamaya may laugh and sell, so let's just make Luzon into U since the second letter is U to be the liters of Luzon produced. So whew, from each warehouse, the liters of each ingredient that you get are going to be given or used for different purposes or one of the two sauces. So basically, meron na ngang dalawang ingredients from each warehouse. But masisplit pa yung variable na yun since they're gonna be used for different things. Like those resources will be allocated to different ano yun? Different sauces. So let's define first, like let's make a loose definition, math style. Math style. So L, IJ, and SIJ. If you don't like this, also you can like write it all out. But you know, for sake of conciseness, let's just make a general definition for it. So L, IJ, and SIJ, L meaning laugh, S meaning sal, are going to be the liters of laugh or sal. Oops. So if it's L and this is if it's S. Bought from a certain warehouse I. With for the purpose of making either the kasama sauce or to make either the kasama sauce or Luzon sauce to make kasama Luzon. So since I is the warehouse number, let's make J whether it's kasama or Luzon. Daming ganap. So for example, L1K, that's gonna be how many liters did you buy from warehouse 1 that you're going to use to make kasama? And this is relevant because the manufacturing of kasama and Luzon are in different plants. So depending on which plant it's going to go to, it's going to incur different transportation costs. So, ayun. And then another example for S naman, S3U, this refers to how many liters of sal did you buy from warehouse 3 with the purpose of making the Luzon sauce? Daming ganap. Anyway, so this Lij, and Sij, we can treat this as like those are totoong decision variables. Like when it boils down to it, we want to be able to every constraint and definition we're gonna write after this. We need to make sure na you can express it in terms of this, since these are the variables, the decision variables that we're going to balance. But no, we don't actually need to solve this because this is gonna be like 12 decision variables. But we just need to have them. Anyway, so basically this means na let's say L, this is the total amount of laugh, the ingredient that you bought. It's gonna be L1K plus L2K plus L3K plus L1U plus L2U plus L3U. So, kasi this is LK, meaning the amount of laugh that you bought with the purpose of making kasama. And then how would you know what the total amount of the total amount of the total amount of laugh that you bought with the purpose of making kasama is the sum of how many you bought with the purpose of making kasama from each warehouse. Just po. So this is LU. Then the total S is gonna be just the same thing. S1K plus S2K plus S3K plus S1U plus S2 S3. This is SU is SK. So this means total amount of S that you bought with the purpose of making kasama. Total amount of S that you bought with the purpose of making Luzon. So this is what I was talking about. This is everything. This is not everything. Sorry, that was misleading. These are your decision variables. When it boils down to it, these are your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 decision variables. Wow. Okay, so since we made our definitions, okay, wait, we're missing one more definition or something that we want to write out. Actually, necessary pa ba siya? Sorry, chine-check ko lang. Mukhang di naman siya necessary, but let's write it down just in case. So Li, Si. Let's make this the amount of L you bought from a certain factory. That's just the sum of the amount you bought from that factory for kasama and the amount you bought from that factory for Luzon. That same thing. For S. Okay. So those are our definitions. Let's go on to our constraints. Wow. Okay. So what constraint can we start with that is like one of the more obvious ones? So K, the amount. Actually, di pa pala yung constraint. This is also a definition. I'm sorry, I'm such a liar. Definitions pa tayo. So let's define how much is gonna be the total K. So K, the amount of K produced. Since we know na after the filtering process, only 90% of laugh can be used. Then K is actually 0.9 of the total L that you have for the purpose of making K. And then since 80% of S will be used, then you add 0.8 of the total S to be used to make K. And then, since we also know the ratio for kasama sauce, I think this one is actually a restriction. So to do the ratio, 5:4 of laugh to sal. You just need to like switch around the ratio and multiply it. Medyo malabo yung pagkasabi ng konod, but okay. It's like 0.9 LK is equal to 0.8 SK. And then you need to have a ratio something here. So since it's 5:4, you just switch it around. So 4 times this. And then 5 times this. So that is the ratio constraint for reducing kasama. 4 times 0.9 L sub k should be equal to 5 times 0.8 S sub k. Okay. That's for making Luzon naman. Since none of the ingredients will be lost to filtering, it's just Lu plus Su. And then since it's 1:1, Lu should be equal to Su. Okay. I need to drink water. Okay. So let's actually make our objective function now. So since we just want to do profit equals revenue minus cost, find the revenue first, then which is 250 per liter of K produced plus 230 per liter of Luzon produced. So I don't know about you guys, but kay Sir Nesty, parang okay naman sa kanya like if the objective function isn't in terms of the actual of these decision variables. As long as the variables you're using are already defined as a sum of these decision variables. So since we already have K defined as itong LK, and this LK is also defined here as L1K plus L2K plus L3K, then we're fine because all of these connect into being equal to a sum of these 12 thingies. So yeah, that's the point of starting off with your definitions so that when you write out your objective function, you can keep track more of like why exactly are you adding this term to the objective function. So this is just the revenue from selling. And then everything else is a cost. So we can start first with one of the simpler ones, which is going to be the cost of the ingredients themselves. So it says here, a liter of laugh costs 50, a liter of sal costs 65. So let's just deduct 50 for every liter, for every liter of laugh used, and 65 for every liter of sal used. And then again, since itong L and S are defined as a sum of our more specific decision variables, we're fine. We're cool. So after that, if we're going by this one, remember that our costs are the cost of the ingredients, the transpo, and the filtering and the mixing. So let's go do the transpo. So transpo is gonna be parang ito yung nagpapahaba sa objective function natin. Since it's gonna be 6 extra terms since there is different transportation costs for each warehouse to each plant. So first, the cost of 5 for transporting ingredients from warehouse 1 to plant K, meaning these are the laugh used from warehouse 1 to make kasama plus the sal used, the sal bought from warehouse 1 to make kasama. Since it's from warehouse 1 to plant K, it costs 5. So if we just follow that pattern for every cell in the transportation costs, we're gonna get something like this. So 10 times L1U 8 times L2K plus S2K minus 6 times L2U plus S2U. Wow. And then, asan tayo? 86. So next is minus 7. L3K plus S3K minus 4 times L3U plus S3U. So, and I just arranged it so that it kind of follows the table of transportation costs. So 5, 10, 8, 6, 7, 4. And you can see the pattern naman. It's from which warehouse to which plant. So since we defined these variables earlier, yay! So actually, I know, not actually. My bad, my bad. I was gonna say you can simplify these stuff, but honestly, it's better to just keep it like that so you don't make a mistake. Then the last one, or the last few, since we covered the transpo costs, it's the filtering and the mixing. So the filtering, when are you gonna pay filtering costs? That is for the liters of laugh and sal that you use to make kasama. So since there's a different filtering cost for laugh and different filtering cost for sal, those are two more terms just for the filtering. So minus 10 for each liter that you put into making kasama, each liter of laugh that you used into making kasama. So that's going to be minus 10 times LK. Since we defined the LK earlier as we did as these three, L1K plus L2K plus L3K. Then minus 15 of the liters of sal used to make kasama, which is defined also. And then next one, the cost of mixing the Luzon sauce is 20 pesos per liter. So since it doesn't mention per liter of laugh or per liter of sal, I mean, 1:1 naman yung ratio nila. So we just use 20 times the liters of Luzon. Right? So that's 20 times U. So since we covered our revenue, our source of revenue, just selling, and then all our costs, which was the cost of the ingredient itself, the transport, the filtering, then the mixing, we should be done with our objective function. So I will maximize there. Now we're done. So maximize z, which is equal to this long thing that spent like 10 minutes writing. And then we do have some more tech constraints before we finish off. So we have these, the max daily supply. And then this one, it's a bit of a sneaky one. Be careful. 12 mixers in plant L, and each mixer can only hold 100 L. So there's actually also a limit to the amount of Luzon that you can make in a day. In a day? Actually, wala namang time frame specified, but I guess we just assume that everything is in the same time frame. So to cover those two, well, not just two kinds of whatchamacallit? Two kinds of constraints, tech constraints. So the amount of laugh you can get from warehouse 1, which is L1, can only be up to 500. And then like amount of sal can only be up to 600. Then let's just write out all of this. And then since these are the constraints for the max daily supply that you can get from the warehouses. Then we have this last constraint, which is how much Luzon you can make, which can only be up to 12 times 100 liters. Then, you can simplify that if you want, or you don't need to, because that's technically correct. And it shows that you have a deeper understanding of why that is a constraint. Anyway, and then for problem 3. Any questions? So, I honestly do not doubt na a question like this of the same difficulty will show up on the exam. But maybe they feel kind. But I mean, if we're basing it on our IA40 experience, the problems are gonna be harder than what we know from the slides. And since yung slides, at least for Sir Nesty, we had exercises na LP formulation, na like 6 decision variables or maybe like 8. Why not 12? So, and just tips. And I said my only tip kanina. The first step is always to try, because nothing is gonna happen if you don't actually try to do the problem. And don't rush it, because especially with LP, you should like properly lay out your definitions para maayos yung pagka-formulate mo later on. So don't be afraid to make use of like making up your own variables, which are a sum of the decision variables, if they make it more concise and easier to write out. Okay. Let me drink some water. Any question? Oh, wait. Do we not need to make a separate DB for each ingredient going from a warehouse to a certain plant, since it might be cheaper to just move to one plant now? Um, no, not sure what you mean, especially with your last sentence. But based on how I understand your question, we do have a separate DB for each ingredient going to a certain plant. That we do. Kasi, so L1K, this is the specific ingredient laugh coming from the specific warehouse going to the specific plant K. And then we have 12 of those for each combination of those factors.
Oh, I thought that was for like the sauce, like L1 from warehouse 1 for kasama because that was your like definition for it. It's not really going to K or J, right?
Sorry?
Like your definition for that is like number of laugh coming from warehouse 1 to make kasama sauce,
Ah, okay.
not like
Because
going
it's
to plant.
okay. Yeah. Because sorry, I think I like skipped over the reasoning. So here, kasama is produced in plant K, while Luzon is produced in plant L. So synonymous yung purpose, synonymous yung like what sauce will it make to which plant it's going to go, since exclusive yung plant K for making kasama, exclusive yung plant L for making Luzon.
Okay, get.
Gangsta. Sorry. It's stuck in my head. So brain rot. Anyway. Problem 4. Okay. I'm gonna be so for real. I hate this problem. So bear with me na lang. Medyo weird siya eh. So consider this LP and the 6 solution cases given. Tapos 4 lang yung given na cases. And then the next page is just the questions na gotta keep pressing the button. Honestly, lucky we can, since we don't have that much time, then we don't need to think much about these questions. Because in the end, what they really want you to do in this item is they want you to just do the whole thing. They just want you to do the big M method. Because I don't think you really have another choice. Unless, I got it wrong. So, we paste this over here. Loves big M method. Oh, fudge. We are family friendly and I love. So, honestly, I had a hard time then understanding what they want us to do. Well, not what they want us to do, but like it relies a lot then on conventions. Since yung isang question is like madadaanan na ba yung iteration if you did the big M method. But it also depends on like which way you're gonna do it. Since diba I mentioned earlier na parang they've been doing simplex kahit hindi standard form or hindi like maximum siya. Hindi siya maximum. So, sorry, ang dami kong sinabi. What I want us to do really is let's just solve this using big M method and disregard everything else because we're gangsta like that. So, make the standard form first. Oh yeah, so since we don't have that much time, let me review us on standard form. So standard form dapat first of all max OF, the objective function is maximized, and then the constraints. The constraints are equalities. 3. It's not a 3. The constraint right hand sides should be non-negative. Tapos, wow, what's the 4th condition? Who wants to help me out? 4th condition. Let's check the slides, everyone. Standard. Ah, that was easy. That was an easy one. Okay, decision variable should be non-negative. So let's standardize this. My questions, but okay. So to standardize, let's make this a max function. They want us to min z1 plus x1 for x2, x3. Let's just maximize it to negative, the negative of it. Z2 is equal to negative 2x1 or x2 minus 5x3. Then x1 plus 2x2 plus x3. Then plus s1 since it's less than or equal to then 2x1 or minus 3x3 minus s2 since it's greater than or equal to, and then also since it's greater than or equal to, we need to add artificial variable r2 3x1 plus x2 3 minus s3 plus r3 is 15. So this is our thingamajig. Our standard form. Then we can lipat it to a table. Lipatize. Dua lipa. 3 is 1 is 2 is 3. R3. Then usually yung basic variables pag ganito is, excuse me, if it doesn't have an artificial variable, just put the s, the stack, and then if it does, then the basic is the artificial. Which number? Artificial variable. 1, 0, 0, 0, 0. Ay, sorry. Big M nga pala. So let's put the M first. Let's put the M then in the maximize function. So we're trying to maximize, diba? So we want to minus an M, minus M R2, minus M R3. Since M is a really big thingy, so that means if our R2 or our R3 are not 0, then it's gonna make it really hard to maximize our function. So here it's M. In case you guys don't know why, like it's negative here, naging positive here, just transpose because it's z minus blah 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 equals 0. Ay, 0 na. May 12 dito. Equals 0. Then, hey, so that's what's off. Negative 2, 4, 5, 0, 0, 0, mm 0. Oh, positive. It should be positive. Sorry, sinunod ko yung nasa item. Positive since transpose. Then it's 1, 1, 2, 1, 1, 0, 0, 0, 0, 12, 2, 4, negative 3, 0, negative 1, 0, 1, 0, 18. Right handed. The last one is 15. 3, 2, 4, 0, 0, negative 1, 0. So this is what we start with, kinda. Like here it says initial tableau given below. Now that the basic variables are not yet normalized. So one of the questions then is like which case will not happen. Like I want to say that this one is something that wouldn't happen because itong m should also be negative. If I'm assuming like nilipat siya as a minimized variable, as a minimized objective function on its own. So if this is meant to be a minimize, dapat yung m is negative also, assuming that m is defined as a positive number also. Kaya that's why I don't like this question. It depends a lot on conventions, like yeah, like that. And then it's also doesn't make sense if it's a maximized function, since as we converted it here to a max function, dapat positive yung x1, x2, x3 if this is a maximized function. So not a right case. A case that doesn't sit right with me. Hold on. Okay. So since we want this, let's say normalize. I don't know if we used that term before, but yeah, we want to normalize the basic variables. So meaning since our basic variables here are S1, R2, R3, dapat sa objective function, S1, R2, and R3 should have a zero coefficient. S1 already does, R2 and R3 don't. So what we're gonna do is Z prime is equal to Z minus M times R2. When I write R2, or like when I'm writing these row operations, I'm referring to its row here, the basic. So actually, if di niyo pa alam yung notation na yun, baka di niyo talaga nag-gets yung solution sa slides. So hopefully, alam niyo na yun. Is a minus M times the row of R3. Whew. And then actually, in-input ko na lang dito so that we can get along with it fast. So I'm just gonna write down the row operations that we did, and then I'm gonna copy this para we don't have to take super long on the manual calculations. But don't forget to practice like actually doing it, because ayun nga, Tableau form is super prone to arithmetic errors, and you know the only way to prevent that is practice. Ooh. And don't refer too hard to this kasi iba yung notation nila. Or here the only way it differs is that the objective function they put it at the bottom. So let me copy this. After you do that row operation, it's gonna be see, this is kind of excruciating. So pag 8:55 na, I'm gonna give up on this, and then I'm gonna just review you guys on the last one last thing that we should review. So just copy this table. In this case, the only thing we need to change is the objective function row, since yun lang usually yung problematic child in the world. So -5, just 1. If 5, let's make it 2 minus 5m. Or minus 6m. What the hell is that? There. 5 minus m, 0, m, 0, 0. That's the right-hand side should be -33m. So remember that m is a really big positive number. And in this case, we're doing the version of big M na you convert it to standard form first. So what we want to do is find our entering variable, which is going to be the most negative coefficient dito sa OF. So when it comes to big M, you pay more attention to the M's, since it's kind of like limits, where if there's an infinity, it just steals the whole limit. So in this case, our most negative coefficient is going to be itong my -6m. So the entering variable is x2. Here, nakalagay here. Entering variable is x2. Then look at the ratios. The column of x2. So that's going to be 6, 18/4. What the hell? Sorry. Anyway, 18/4, which is 9/2, 4.5. 15/2, 7.5. So the smallest one is 4.5, which is of the row R2. So the leaving variable here is R2. So when we have a leaving variable and entering variable, or what we want to do is on the row of the entering variable, dapat ano siya, in this case, since it's going to replace R2, dapat, it should be 0, 0, 1, 0. So it should be 1 on its row and then 0 on every other row. Yes? And that column should be yung corresponding column niya on the top headers. 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 Okay. So, paano yan? First thing we can do, since we just want to make this one, make it so that R2 equals R2 over 4. And then, since after that, itong spot is just going to be 1, we can use that to do row operations on everything else. Whew. Next, after that, it's going to be S1 is going to be equal to, S1 prime is going to be equal to S1 minus 2 R2. R3 prime is going to be equal to R3 minus 2 R2 also. After we do that, sorry, last one. Z prime is going to be equal to Z minus 4 minus 6M R2, since you want to zero out this thing at the top. Weird lang talaga siya as hell. Anyway, so let's copy this table again. Mag 855. No, please. Please. So this is our iteration 1. Wow. I sure hope it does. And then remember, since R2 exited, we don't actually need to calculate for it because dapat pag big M, once an artificial variable leaves the the basis, it shouldn't come back. So thankfully we don't need to do all that. Then let me just copy down the values. 2M 0 negative 11 8 minus 11 over 2M 1 minus 1 half M oh sorry, I skipped it. It should move over 1 box. S1 is 0. Don't need to write that down. Then 0 and then 18 negative 6M minus 18. Then everything else 0 1 half 2 0 1 0 5 halves negative 3/4 11 over 2 just go 1 0 0 1 half 1 over sorry, that's since R2 left, we should change this row header na or row header. Instead of R2, it's actually the row of X2 now. Okay. And then half 1/4 half 0 0 negative 1 1 half. Oh wait. Actually, yeah, we still have to write it down. 1/4 negative 1 half 0 0 1. Okay. Where are we at? So now we have a new iteration. We just find a new EV and a new LV. Whew, okay. Dito abot. Anyway, for EV, it's going to be the most negative pa rin. So if you look through all that, the coefficients of M specifically, we have negative 2M, negative 11 over 2M, negative 1 half M. So yung most negative is X3. So X3 will enter. Then the leaving one's going to be the ratios. Oh, sorry. Mali yung na-copy ko for this. Okay. Yung negative 1 half is for the variable that left. So this is just 0 0 1. So it's 3 9 half 6. So the ratios, where is our entering variable? X3. The ratios are 3 times 2/5 be 6 over 5. Then, oh god. Well, you don't care what this is because it's negative. And then 6 times 2 over 11 is equal to 12 over 11. Then if you know the 6/5 is actually 12 over 10. So, fractions, you know that the smaller one is 12 over 11 because 11 is bigger. So our leaving variable is R3. So R3 is going to leave the basis. So we're going to end up with, okay, since 8:55 now, I won't write it down. So we're going to end up with, what's the name? Here. So in R1, this A1 here is R2. A2 here is R3. So we actually don't need to calculate all of those. So, ay, tama ba to? Okay, wait, sorry, I skipped. This is the one that we care about. Oh. Anyway, so basta what you're gonna end up with dapat is, okay, sorry. Ang gulo ko today. Anyway, since we know R3 is leaving na, that means all the artificial variables are gonna leave. This is medyo more conceptual that you need to remember. So listen. So R3, since it's leaving, dapat wala nang matira na M anywhere except on R2 and R3's columns, which we aren't gonna compute for. So before we finish up this X3 thing, let's try to remove all these M's. And if you look conveniently, this -2, then the coefficient of R3 on that column is 2. Then 11 over 2, coefficient here is 11 over 2. Then 1/2, 6M, -6M minus 18. So what we're just going to do is, before we do anything else, make sure that we change Z to Z plus M R3, just to cancel all of those M's in the columns that we don't want them to be in. Then after you do that, proceed normally with, making what you need to do. Okay, I'm sorry that we can't finish that problem, but I just want to go back to if we have, let's review what we do if we have variables that are negative or variables that are unrestricted. Ano pa? Pa yung cases na. Anyway, so if we have variables na are gonna be negative, just remember that in the simplex you replace it with a variable na just the additive inverse of that, which is a fancy way of saying the negative of that. Then this one, how do we say this? We split x1 into x1 plus, x1 minus, so that these are both non-negative thingies. Yeah. Yan lang ba yun? Are there other things that we need to accommodate? I think parang di naman. Let's check the slides, everyone. Saan slides pa yan? Okay. Min to max. Oh. Okay. Ayan lang siya. Then yun din, if the constraint is like x1 plus x2 is less than or equal to negative a, where a is greater than or equal to 0, so basically a negative number, just multiply it by -1, x1 minus x2 greater than or equal to a, so that the right hand side is positive. Yeah, I think that's all. Unless you guys want to stay and really finish this big M thing. We should be done. I can finish up this big M like maayos na solution and then I'll send it na lang when it's done. Since it's late in the day. Yeah? You guys good? Any questions about Big M? Kasi the rest of this should be standard na since lumabas na yung R3. So at least umabot tayo sa how to deal with artificial keme-keme. Is there a question? Ray, TY. Goods. No problem. Thank you. Sure na walang question. Sorry that I was late. And sorry na magulo in some parts. I love you guys.